Programming Throwdown, episode 174, DevOps. Take it away, Jason.
Hey, everybody. This episode, we're going to cover DevOps. For people who are new to the show, we're going to cover it somewhere in the middle. We'll talk about news and some other things first. That is the number one comment we get is, why did you take so long to talk about DevOps? And you're going to learn a whole bunch of cool stuff today. If you're a brand new listener, welcome to the show. So I wanted to kick it off with a project that I built, which I'm pretty proud of. It's one of these things. You probably have this feeling, whether you're doing woodworking or stuff in the backyard or robotics or anything. You have a project and you say to yourself, "This is a coin toss, whether this is going to work or not," and it's kind of exciting. It's like it's kind of like a rush because that sort of randomness, right? And then, as it really is a coin toss, half of them, don't work and just decay into dust. Half the projects work really well. This is one that I feel like works pretty well. I created a LinkedIn social media bot, but it doesn't do what you think. Most of these bots go out and like harass people, or maybe that's not the right word, solicit people, right? Mine is the opposite. So mine is a defender. It defends me against the other bots. And so the way this works is it uses large language models. So I'm using ChatGPT. It has, like, in the cookies file, uses a headless browser with the right cookies set up. So it's logged into my LinkedIn account, goes on LinkedIn, accepts any, connection requests, and then goes to my messages, looks at the unread messages, and I ask ChatGPT, is this a solicitation? Like, is this someone trying to sell me engineering services? And I tell ChatGPT, answer yes or no, followed by an explanation. And the next one's, is this somebody who is looking to work at my place of work? And based on these answers, it sends automatic responses. And so I actually, in the response, I tell the person, hey, this is an automatic response. Your message was classified as this for this reason, and I paste the ChatGPT answer. And then I mute the thread and put it in the other category. And this has worked amazing. So first off, after some testing, I kicked it off. I got banned 3 times from LinkedIn because not banned, but like throttled, or like literally, if from my desktop I went to LinkedIn.com, I just got like a HTTP timeout or something. So like they throttled me completely. But eventually it went through my entire backlog of unread messages. And and the other thing it does is, if it doesn't catch this as a solicitation, it marks it as safe. And so I have a safe list. And so when I was done, I looked at, because I had thousands of unread messages and it was almost all spam, right? But then when I was done, I looked and there was all these people who were legitimate people who had interesting things to say, who I now could see. It's like basically like I had a handful of needles, like the haystack was burnt to the crisp and what I was left with is all the needles. And so some of the people I reached out to were surprised. One person was upset that it took me 8 years to respond to them.
Whoa.
But a lot of people is like, I built a lot of connections with people who just, serendipitously, like, or just, messaged me on LinkedIn and I just couldn't see it. So it was an amazing experience. And so now what I did is created a cron job that runs on my Raspberry Pi, which runs the same process every hour. And for example, at 4 a.m. and at 9 a.m. today, it sent automatic messages and muted 2 people who are trying to sell me software services. So that's just today, this morning. So it's pretty awesome. It's kind of weird, but it's pretty cool.
I think the idea is interesting. I mean, I guess the incentives in the system are a bit weird because LinkedIn doesn't really have an incentive to stop the spam as long as if like it doesn't overwhelm and like mess up user retention. So like some some people may like it's also a personal thing. Like some of the stuff you might consider spam, other people might consider like if you're searching for a job, some of those people reaching out may be like, oh, I want to reply to them, like I'm job
Right.
hunting.
Right.
And so yeah, I mean the getting throttled, it makes sense. It's very hard to distinguish between someone doing like what you're doing and someone, scraping a bunch of hacked LinkedIn accounts that, trying to get everyone's personal data. But
Yeah, I mean, I was definitely nervous when I got throttled that like I had inadvertently got myself kicked off LinkedIn. Yeah. So just to double down on that, for friends, I have friends at LinkedIn, and you guys totally did the right thing by throttling me. I don't feel like that was in the wrong. I'm glad that it didn't last forever. Um, oh yeah, you hit on something really important, which is there's this spam like, hey, I'm in Nigeria, I have $1 billion, I just need you to send me your credit card, and then there's what you said, which is like I think solicitations is the better word, and in fact, like even this ChatGPT thing, the very first thing I ask is this a person um looking to offer me a job? And if it is, then I mark them as safe. So like clearly, like there's some
okay.
solicitations I'm interested in, and then others I'm not. And I don't expect like LinkedIn to mark those as spam, right? Or have that nuance.
Yeah, so I guess like that's one of those I guess you call it fine tuning or whatever, like at the limit being able to describe your preferences in a maybe just a, chain of consciousness style like way you're thinking about it and having it tuned to those preferences. Like I am interested in jobs that are legitimate, but I'm not interested in job offers that are clearly just blasts and have none of my personal information in them. Like the person didn't bother to do research. And you can kind of list off all the things you're interested in and kind of build the yeah, like you said, like you can do a lot of probably what you're doing with natural language filters or just like going in and doing basic stuff. It just, you wouldn't take the time. It's not worth it.
Right, right. Like for me to build some NLP thing, it would take me a long time versus this only took me maybe 3-4 hours. Um, and the false alarm rate is not the best. I actually somebody texted me and I had muted them on LinkedIn, and they actually knew me from a meetup that I run here in Austin, and they sent me a text. So yeah, there's definitely the false alarm rate is let's say 5% or something, which is not great. Um, but for an application like this, I think it's fine. I'm not landing a space shuttle or anything with this, but it definitely, when you go and look at all the people messaging you and you auto messaging them and muting them, like every now and then I'll go and look at it. It makes me think of what a weird world we live in where someone has, a machine that messages me and my machine answers it. And it's all like natural language. Like it looks like they messaged me, manually, and it looks like I responded to them manually, but it's all just fake.
I
So
think I think that was on I think it was Lex Friedman talking to Jan LeCun and LeCun was saying the same something similar, which is we always think that there's going to be some propaganda campaign that somebody's going to use Chat GPT to just be super convincing with fake news. He's like, what people miss is that if they can do that, you can too. And so a lot of our email and correspondence at some point in the future, likely it was astonishing that we effectively ran open ports and like let everyone just send everything they want to us. And instead we'll have
yeah.
secretaries that are trained on our behalf to like filter out that stuff, and you'll just have your bots talking to their bots, and some stuff will get through, but most of it, will be sort of caught by intelligent filters on our side. And so
Yeah.
they'll develop together.
Yeah. I mean, Scott Galloway from the NYU Business School had this talk that I watched where he was talking about Amazon having this unfair advantage because if you search for just the word batteries on Amazon.com, you got their batteries first, and how that's just a huge advantage for them. I don't think he was going down the it's not fair route. I think he was more just saying what a tremendous advantage it is
Yeah.
for them. And so you could imagine a future where when you search for something on Amazon, there's some browser plugin that re-ranks it, that has your interests. And so now like your ranking kind of fights with the server's ranking.
Yeah, it's an arms race. I mean, it sort of sounds appealing to engage with social media in a way where it's like, I want something to go through and curate stuff on my behalf that works for me and incentivized by me, rather than the social media companies trying to get engagement or push just absolute crap to me or try to get me to stay on longer to find the nuggets, right? Like they're incentivized, right. Even if they 100% know the things I'm interested in, they're incentivized to spread them out at like a specific repetition interval so that I spend more time, see more ads. And so they keep showing me other stuff that's maybe just close enough that I don't click away or whatever. And so to have somebody go through and filter all that out, it ruins all the advertising models, of course, but it does sound an interesting way to consume media.
Yeah, totally. So yeah, folks out there, if you want, connect with me on LinkedIn. I will accept everybody, and then you can send. I will literally accept. Well, I won't accept it, but my AI will accept it.
Convince Jace's AI bot, and he'll share with you.
Yeah, if you message me on LinkedIn about your software development company in Eastern Europe and how they can do software cheaper than I can, or whatever it is, you will get blocked, and it will be pretty funny. All right. On to one last thing about that. The code is also totally available on GitHub. Just look me up on GitHub. There aren't that many Jason Gauchis. Find my most recent repository. You can get all the code and run it yourself. All right, on to news. My first news. So when I was building this LinkedIn autoresponder, I used Amazon Q, which is one of these Copilot type things. Patrick, have you ever used GitHub Copilot or Amazon Q or any of these?
No, I haven't. I mean, at my work, it's sort of banned, and I, as I've admitted many times on here, I don't do as much coding as a hobby as I should.
So it's also banned at my work. So this was my first opportunity to use it. Banned isn't the right word. It's more just
exactly.
It hasn't been considered. Maybe is better.
Oh no, for us, it's like it's you don't want to upload your code to somewhere, right, in order to get comments on it.
Oh, I don't know if this one even does that though. Does it do that, or does it just run?
Most of them do, or at least have clauses that they could upload portions of yours.
Oh, that's something I didn't even think about. I just assumed that it was running on my desktop, but you're probably right, actually. Okay, at any rate, so I tried this out. It was awesome. So I'll give you some examples, like really concrete examples of things I found really impressive. So, and these are all going to be tiny. So this is part of it is, the whole like build me an entire website, ChatGPT. I've been extremely skeptical of that for a whole bunch of different reasons. The biggest one is that projects are many modules that you want to have like some thematic consistency, right? So I kind of went in pretty skeptical, thinking this is not really going to help. But one thing that it did was, I had a variable called finished, and I had while not finished, and so then later on inside that while loop, I think I put finished equals. Let me see if I get this right. Oh no, sorry. I had while true, and I had a variable called finished, and then I typed if finished, and then it auto completed, colon new line break. So again, like not like a big deal, but like it kind of figured out like, okay, the variable is called finished. It's inside a while true loop. So if it's finished, you want to just punch out of the loop, right? There was another thing where, so I was using this library called Playwright to do the web automation. And when I went to run a function, it figured out that I should set this parameter. There was like a wait time parameter, and it looked further up and figured out, oh, I'd set this wait time parameter before, and so I'm going to want to set it again. And so right when I put the open parentheses, it was like wait time equals 2 seconds or a constant or whatever it was. So it was impressive. I actually was really, really surprised. I was very skeptical. I was expecting to just uninstall it right away. There were a couple of times where it wanted to auto-generate like 30 lines of garbage, like literally just garbage characters. So it's not perfect by any means. But it was, I would say it's a net productivity gain. I was really surprised.
And you feed it your like context of your entire project in advance, or it's doing this from like common available code? that it knows
So
about on
I
GitHub?
have no idea. I mean, basically, I'll tell you what I did as a user. I installed the extension. It makes you create an AWS Builder account, which is separate from any other
Okay.
Amazon or AWS accounts you have. So I had to create a new account, and that was it. Under the hood, it could have uploaded my entire project to the internet. I really have no. I mean, it was an open source project, anyways, so I had
Yeah.
nothing to lose. But yeah, I really don't know what it was doing under the hood, but it was really clever.
I look forward to this. I mean, I think this will be one of those things where it used to be. I remember that was a long time ago. Google used to sell search appliances, and
Oh yeah,
for the
that's
same thing, you
right.
would put them on your infrastructure internal on your network at a company, and it would index all of your internal websites and web pages, so you could go to like an internal Google. Now a lot of that, has been integrated in other tooling and other solutions. And so we don't really think about that anymore. But I think something similar will happen here where you'll have on-premise boxes initially, because it's the only way to really guarantee, I guess, it's sort of safe, or AWS instances maybe. And you'll upload company, your repositories and have this stuff crunch on it.
Yep, yep, that makes a ton of sense. I know there's a bunch of open source versions of this that you can run locally or run in your own cloud. So I know the technology is there. It's just a matter of time.
Very cool. Mine's on a pretty opposite end of the spectrum, I guess. And that is, I've seen a series of these. So I just want to highlight, I picked one to focus on, but there's actually two, which is there's a series of very cheap RiscV or RiscV. I don't remember what we
Risk
decided last
five.
time. Yeah, RiscV. Okay, that's what I was going to say. The RiscV processors are starting to kind of roll out. And also I saw like commodity prices. So I think they're like 10 cents roughly for one of these processors.
Do you
There
have
have been
any?
I don't have any yet. It's on
Oh,
yes, I have them in my cart on AliExpress, but they're kind of expensive
okay.
there. So I need to find another place to buy them from. And
Yeah,
waiting
I
for
was.
some.
I found them very expensive as well. I was looking at the Mars something, and it was like $200. I was like, I can get
Oh,
a Raspberry Pi
geez.
5 for that.
So okay. So maybe these people are out to help us. So a YouTuber by the name of Bitluni, Bitluni. If you've never seen him before, lots of interesting computer related projects there. He built a super cluster of 256 of these with some interesting discussions if it's not something you've ever considered before. But if you want to have 256 processors talking to each other, how do you handle that as like putting them on a bus? And what does the communications matrix look like? And how do you organize it and think about it? And then, how do you tell if they're all working or not? And he's not of course, other people have built, very high core count, even production processors before, but at a hobbyist level, it's kind of nuts. You would never have spent whatever it is, $5 for a processor and then 256 of them. But at 10 cents each, and PCB prices have come down to sort of make your own boards. And so it's just an interesting time to kind of consider some of these. And the nice thing about these, which I think there's a pair of them that are pretty similar, CH32V, I think one is 003 and the other is 203. So CH32V203. These are the chips. But often what happens is these chips are very, very cheap. And if you get help from the company and you need to put them in like your hair dryer to display, to control the temperature output or something, you could buy one of these. But if you want to do hobbyist stuff with it, getting an SDK, getting documentation is pretty hard. So you need a sort of critical mass of people to get, good English translations and SDK. And the very, very popular, I guess, example of this is if you hear people talking about, oh man, what? I just thought no, not the STM32. What are the little Wi-Fi chips? You were using them, Jason. Oh, why is my
The Pico, Raspberry Pi Pico.
no, now my brain failed me. This is a bad
Oh, the
segment. Anyways, yeah,
ESP32.
thank you. I was going to say STM32, but it's ESP32. Those are two different things. The ESP32 was similar. It was like a very cheap commodity thing that was like going in light bulbs and it wasn't
Yep.
useful. And then hobbyists sort of realized, wait, this is actually, we can get good documentation for it. And now there's a huge, community of people developing things for ESP32 and other chips. And I don't know for the company if it made an impact or not, but for hobbyists, it's certainly cool to get access to these really cheap things from this Espressif, I believe, is that company. So now we're starting to see the same thing: debug tools, compiler tool chains, for these RiscV processors, and they're ridiculously cheap. In part because they don't have to pay a licensing fee for the RiscV architecture itself, and so you can get them even cheaper. Not that everyone always pays licensing fees, but for sure now, like they definitely can. And then in the show notes, I don't have a great way to do it, but if you search powering a Nixie tube from a RiscV chip, you'll find there is a link here to a YouTuber who I hadn't run across before, but they built a like a buck boost controller from a microprocessor. So actually taking USB sort of 5-volt power and like going, I think it was 200 volts to power a Nixie tube, which is a little like vacuum tube, except it displays numerals instead of like doing a transistor. I think it's, I did a CNL OHR. Look in the show notes or search powering a Nixie tube from USB with a 10-cent RiscV processor. And so they, I guess, were doing something not coordinating with the other person, Bitluni, but they both end up having something. They have a bunch of cool stuff on their channel as well. So worth checking out. So adding this definitely to my list of like things that would be cool to play with. And as Jason has told us on the show before, there is a risk of letting out the magic smoke. So spending, 10 cents on a processor makes letting out the magic smoke much less painful.
Yeah, totally. I feel like just personally at the level where like I have to put the processor somewhere and put the RAM in another spot and the Wi-Fi chip in another spot and hook them all together, that's like one level below where I'm interested. Like that's why I was looking at this Mars thing. I can't remember the exact one, but it was basically a Raspberry Pi where you have the Wi-Fi, you have the Bluetooth, you have an Ethernet port, an HDMI port, all that stuff, but it's RiscV. And for some reason, those are still really expensive, but I think it might be just that they're not mass producing them yet.
Yeah, I think they'll come. I think the dev boards, I'm seeing dev boards in the sub $5 range for some of these CH32s. I don't know what the proper abbreviation is, but for these, but they don't have Wi-Fi and stuff like you're saying just yet.
Got it. Yeah, that makes sense. All right, my next news story is Phi 3 Vision release. So a bit of background here. Microsoft has been pushing, a lot of things, but among them, these SLM, small language model. And so the idea is, this is a model that I actually have one running right now on my phone, and it's pretty good. It runs in real time on my Samsung. It's not even really the latest model or anything. So small model. It will give you some weird answers for sure. It definitely doesn't have the depth of these other models, but for general queries, it works pretty well. I had something recently. Oh yeah, so there was some issue with Verizon. We ended up having to call Verizon, our cell phone company, and get it sorted out. But for whatever reason, my entire family lost internet, which was actually kind of terrifying when you're on vacation. We were on vacation and we still could make phone calls and text and everything, but we lost the actual internet, mobile data. And so I was, downloading maps when I was on Wi-Fi and all of that. It was a mess. But one of the things I did is I was asking this Phi 3 because it was local on my phone just for some general queries, and it was giving me answers. So it's amazing. And so now they released Phi 3 Vision, which is an actual like multimodal model that you can run locally pretty easily. So people have done a lot of really interesting things with this. You can actually, I have a friend who took a photo of his driver's license and asked Phi 3 Vision, hey, pull out the birthday and the driver's license number and the person's name out of this photo. And it did all of that and stole his identity. So it's, no, I'm just kidding. But no, he ran it locally. And so, he's totally safe. He knew that it wouldn't hit the cloud or anything like that with his driver's license. He gave it a few other PDFs and asked it to, extract information. And he said it was amazing. He said everything came out flawless. So, I think this is just, really something to pay attention to. There are better models like Lava, which is a multimodal model. But these require, GPUs with 16 gigs RAM or maybe more than that. And so they're heavier models. It's really interesting to see, like, for an average person with an average desktop, laptop, or even a phone, what are we capable of doing here? This is really taking that to the next level. So you can check it out. It's pretty easy to download, and there's something, I'll put it in the show notes, called Ollama, um, where it will basically hold your hand, and you don't need to be even an engineer or a coder to use these models. It gives you a like ChatGPT like web interface, but for open source models. So this is a super low barrier of entry, and I think there's a ton of potential here. So if you're out there, college, high school, just getting started, check this out. I think there's some real powerful stuff you could build on this.
Very nice. I do have a couple apps that will run open source. I think Hugging Face, there's an app. I don't know if it's an official app or not, but lets you from your phone hit those. Those aren't local though, but yeah, it is kind of cool to try the various ones and see various ways you do or don't that they can kind of fall over. But the multimodal stuff is cool. To dovetail it right into my next one, that's talking about multimodal, is OpenAI. Well, I mean, news all the time these days, controversies and new releases,
Yeah.
but just focusing on a new release, released ChatGPT 4.0, which the O being Omni and sort of their take on this multimodal. So being able to use pictures or voice. The demos are really cool. Sometimes a bit hard to recreate the demos if you try it yourself, but in general, pretty exciting to say, like, hey, I'm sitting here with someone who speaks Russian. I only speak English. Like, I'm going to speak English, and I want you to translate it to Russian. They speak Russian. Just describing.
Yeah.
You're like, oh, I could do that with the translator app. It's like, yeah, but now you don't need to. Like, for arbitrary configurations, it can kind of understand. But also some of the behind the scenes things that they're sort of saying that, running this new version, even though it's improved, is just like orders of magnitude cheaper. They're figuring out, not really. I mean, you can kind of read the rumors about next version of ChatGPT 5, but it's kind of cool to see them get more and more efficient at running their current generation stuff, sort of almost faster than you would expect. And it's just interesting to see how quickly things are moving, and how the pace goes for training and running a lot of these models.
Yeah, definitely. I'm a really big fan. I think OpenAI started by doing reinforcement learning, which is obviously near and dear to my heart. I don't know if they do much of that anymore, but still, I'm a big fan of the company. I think it's really cool. There was complaints about them, like I guess stealing somebody's voice or stealing like data from the internet. They've stolen all of my code, but that's okay because I stole it from Stack Overflow. So I copy pasted it first. So how can I hold them responsible? So no, I think, well, I mean, that's a whole rabbit hole around data. And, if you scrape Reddit, are you like, trouble or whatever? But either way, I mean, I think it's amazing. Yeah, I think the 4.0, the ChatGPT 4.0 stands for Omni because of the multimodal part. And I think there's so many interesting ways you could take this. I mean, one thing that just came to mind is, you could run. Oh, circling back to what something you said earlier, the app that lets you actually run the models on your phone is called MLC Chat, and you can get that. I think it's on iOS and Android. But yeah, imagine like you take a picture of like even just a restaurant receipt, and it keeps track of what things you've eaten at restaurants. I think there's a whole bunch of cool stuff you could do with this, and we'll have to see where people take it.
All right, time for book of the show. My book of the show is not a book. Spoiler alert, my tool of the show is also not a tool. Book of the show is a podcast. This is a bit of a different podcast. I don't want to give like a ton of disclaimers. I've been enjoying listening to it. It's the MyFirstMillion podcast. This is like two business folks who are kind of like doing marketing, but they have interviews with people who have sort of done startups or sold companies, and they talk a little bit about details about kind of exact dollars they were earning and how marketing goes. They were talking to someone recently who had a blog about gardening and then started selling products and turned it into. What I find it interesting is it makes you think a lot about stuff that's pretty different but adjacent to the stuff we do. I think a lot of software engineers always have this question about entrepreneurial pursuits and like what the various trade-offs. These folks are out talking to people who have done massive things, people who've done small things, and also just their observations. It's a very casual podcast, a bit long-winded. They also don't necessarily get to the topic of the podcast until late into the podcast, but they release twice a week, and it's a very casual listen. I've been enjoying it. I don't know that I'll listen to for always and ongoing, but it's been good to sort of listen to kind of the sales aspect, marketing, the kind of parts of the business that I don't normally focus on, right? I'm always thinking about solving hard problems and machine learning models or whatever, right? Like those things are much more up my avenue. This is adjacent and people doing often software businesses, but talking about motivations and things, related to personnel and, how to relate to people. And anyways, personally, I've just been finding it a nice orthogonal set of views, I guess, to what I might normally pay attention to.
Yeah, that's awesome. I'll have to check this out. Jason Fried, that name sounds familiar. Is he the Basecamp person or is that somebody else?
Yeah, he was one of the ones, him and DHH or whatever.
Yeah, okay, there we go. Yeah, very cool. Yeah, I'm definitely going to check that out. That looks like fun. All right, so totally on the other end of the spectrum, my book is one of the geekiest books I think we've had on the show. It's this research paper from Jan LeCun that he wrote in 2022 called A Path Towards Autonomous Machine Intelligence. And I have a link to the PDF in the show notes. It's not an approved paper. It wasn't submitted to any conferences. It's just an open paper that's written on Open Review, and you can kind of tell. There's some language, errors, grammatical errors. There's some hand wavy stuff. There aren't really any. Actually, I think there's literally no results section. But sometimes these are the best papers. It's just like raw thoughts of folks. And so this paper is really interesting. It tries to tie together, these really large latent models, right? So large language models are, and I think we're starting to use foundational models because they are multimodal. But these foundational models are forward models, which means they look ahead. So it says, given I just wrote this part of a paragraph, what's the next word I should write, or what's the next handful of words I should write? And so you could extend that to really anything. You could say, well, given that I made this move in chess, what's the next move I should make? Or given that I turned the steering wheel this way in this car, what should I do next with the car? So there's sort of like a theory of everything kind of thing going on here, where the idea is you build this massive world model that tries to predict the future, and then you do a variety of different things like sampling and some gradient based search and different methods to search through potential futures. So, I mean, maybe taking a step back. So, you have the world you're in. Imagine you are. It's a good problem we can use for this. Just let's take chess, for example. Chess. What about, okay, let's take chess where instead of, you getting a chessboard the way a computer you would expect it, you're getting pictures of a chessboard. Okay. And so you have to play chess from looking at pictures of a chessboard. There's a lot of things that really don't matter, right? Like if the pieces start casting a shadow in the opposite direction because there's a new light source, that's not relevant to the problem you're trying to solve, right? And so if you look at ChatGPT, ChatGPT is taking text and trying to produce more text. So it really has to understand everything about text. But in this case, you're not really taking in a picture of a chessboard and trying to create a picture of the chessboard with your move on it. You're trying to take in a chessboard and make the move, right? And so there's a lot of confounding information there, like shadows, for example. So the idea here is you create like an embedding or like a low level projection of the image. Um, and then you try to predict the low level prediction of the image with your move in it. So imagine I say, here's a picture of a chessboard, and I want you to give me a picture of the chessboard where the pawn has been moved up a square. And so, but instead of literally rendering that photo, which requires a lot of wasted time, it creates sort of this low dimensional representation, and then a low dimensional representation of the board with the pawn in the new spot. And then what you could do is you could physically move that pawn, take a picture, and then embed that picture and see if it worked. Right. So did the embedding of the future match the embedding of the present plus this function that's supposed to take it into the future, right? Um, and one thing that you'll quickly notice is like you can hack this, or you could exploit this. You could say, oh, well, my embedding is just the zero vector, and all actions just turn the zero vector into the zero vector. And so I embed to the zero vector. I move the pawn. Now I have the zero vector. I embed the future, which is also the zero vector. And sure enough, the zero vector equals a zero vector. And it could seem like my embedding is amazing, but actually it's not doing anything useful, right? And the way they get around that, which I thought was super, super clever, was I'm going to see if I can explain this easily. Um, they try to maximize the information of the embedding. And the way they do it is, if you have a picture, right? And we've talked about this on the show in the past, like it's little RGB values for each pixel, right? And so it's like a ton of these like RGB values, right? Um, and then when you crush it down into this embedding, now it's like a small number of numbers or dimensions, but it's trying to like accomplish some goal. And the goal in his case is to do this forward thing we talked about, but also he wants the variance of the parameters to be as high as possible. So basically, trying to make fancy way of saying trying to make the numbers vary a lot from one picture of a chessboard to another. So if you take a bunch of pictures of chessboards and they all collapse to the same embedding, you could assume that it's not doing a good job. Now it's possible that like nothing has changed, but it's also possible that you're not doing a good job of capturing information. So yeah, that's just part of the paper. I mean, this is a 50-page report. So there's a lot of content here. The thing I like about this is you don't really need to know anything beyond like just algebra and some understanding of like differential equations to like grasp this. It doesn't like refer to like a million other papers um, that you then have to go read. So I think it's one of these things that like folks who know DiffyQ, or even if you don't, you could read this paper and get a lot out of it. It's a good kind of starter paper, but there's a lot of content too.
And this is part of his thing. Like, I mean, I think he's talked about this, but the contention that the current machine learning stuff, like the LLMs, can't really do planning. Like it can't sort of figure out how to do stuff. It can describe the text of a plan, but it itself doesn't do planning because it doesn't sort of move through the space like you're talking about. And this is related to that.
Yeah, that's right. Yep. So he actually famously put on Twitter, like if you're in college right now, or if you're getting a PhD right now, don't bother with LLMs because like the companies are all over it. He's like, do the thing after LLMs, which I think is absolutely correct. Like this LinkedIn thing we talked about at the beginning of the show, like take an LLM and use it to do something, and you will uncover like the next layer of problems. But yeah, I think it's interesting. Even in this paper, he's really casting a lot of shade on contrastive learning and LLMs and these things in favor of some of these other approaches that he talks about in the paper.
Very nice. Yeah, I if you have been paying attention to, I guess X, is it that recently there was shade being thrown between Elon Musk and Jan LeCun about being scientists and writing papers. And
Yeah.
anyways, feel free to go read that thread if you want some drama.
Yeah, exactly.
All right, it's time for tool of the show. As foreshadowed slash spoiled, mine is not a tool of the show, but it is a game. This game is available, I think, on actually various consoles, Xbox, PlayStation, but also I've been playing it on my Steam Deck, and that's Dave the Diver. It's just like one of those things. If you tell someone you're playing a game where you're like a slightly out of shape spear diving fisherman who goes and collects fish and then runs a sushi restaurant by night, it would just be like, what? But it actually works. It's kind of fun. And it's I guess you would call that, I'm going to misuse the term anyways. It's a bit of a rogue-like game in that you sort of have the cycle of going down and doing the fishing repeatedly. You're not meant to sort of win it. You're just progressing. And you can do better or worse at going down and catching the fish. But then you go through the cycle of serving the sushi and earning money and upgrading your equipment. And then you can go again and you can learn, get equipment that helps you dive deeper and have better weapons and fend off, things trying to eat you in the sea. And so the game sort of progresses. I've not beaten it, presuming that there is an end game. I've not gotten there yet. Still, and there is a story along with it that I won't spoil. But it's just sort of like a fun, you don't have to really play for a long time. The controls are kind of cleverly done for how to sort of line up your spear and shoot your spear out. If you're not into, I guess, fish cruelty, definitely stay away. It does involve eating sushi, so it has to be procured somehow. But definitely like a fun game, well done. Like the art is kind of a pixel art style, so it's kind of fun that way. But the gameplay just is cool. And if you only have like 5 minutes to play, you can go on one of the dives or whatever. You can play for longer, but you don't have to like sit down and be like, okay, I'm putting 90 minutes into this. And so I've been enjoying that.
Well, what happens when you die? Like, how does he make it to the next day if a fish literally eats him?
So I think it just sort of hand waves over that part. So if you're collecting up fish and there's like a limit to how many you can carry, like a weight, so you die, like you lose everything you're carrying. But I presume he has some sort. I don't know that I remember exactly how they hand wave away the fact that you return to the boat and you can try again.
Got it. Okay, that's cool. I'll have to check. I've heard good things about that game, so I'll have to check it out.
Yeah, I was very skeptical, but it works.
Very cool. All right, my tool of the show is also a game, but very, very relevant. It's called Turing Complete, and I learned a ton about like low level engineering, like electrical engineering, I guess, or computer engineering from this game. So literally, the first level they give you, and Patrick, you're going to know this. They basically give you one of the gates, and you have to build all the others. I think NAND. Is that right?
Yeah,
Okay, yeah. They
normally
give you a NAND gate, and they're like, make a NOT gate. They're like, make an OR gate, make an AND gate, and so you build all the gates from a NAND gate, and then as you build things, they end up on your toolbar. So it's because it's very modular, right? So it's like, okay, now I don't need to make the NOT gate. As soon as I build it, I just have it now. Um, and then you get all the way to where you like build registers and you build like an ALU, and then you end up like creating your own assembly code. So you learn like in the beginning they give you assembly code without like arguments. So like you literally have to be like, if you're moving memory from this register to that register, you need to like have a named instruction for like all possible pairs of registers. Um, and then it gives you like assembly code with arguments where you could just have like a move operator, or like multi-symbol, I guess, assembly code. And then in the end, you end up like creating things that shoot down asteroids and solving mazes and doing all sorts of crazy stuff. You play Space Invaders. You build an AI to play Space Invaders. And like you can actually then like drill down. Like you could build the AI to play Space Invaders, and if you're inclined, drill all the way down to like an individual NAND gate in this computer you built. It is unbelievably satisfying. It actually taught me a lot because, as people know, like computer engineering is not my background, and so I learned a lot by doing it. um, it gets really, really hard. I was able to get through the whole game, but I think I would say the mid to end game is pretty much inaccessible for people without an engineering degree. I don't know if I'm just like taking my skills too highly there, but I feel like if I feel like a person's gonna have a really hard time with the last few levels of this game, um, but that's okay because you've experienced so much of the content already. And maybe it would encourage people to go and get like a 4-year degree or something. Um, but it's there's a lot of complexity, but a ton of fun. The UI is really well done. The way you place the circuits, and you can color code the traces and everything. Highly recommend it. Definitely worth the. I don't think it's even that expensive. Definitely worth the $20.
I think we mentioned that one in passing before, but this is like definitely a good review of it. I've not tried it, so now you make me like want to go do it. But I know I'll also hate myself having done that bottoms up thing a few times in a few different contexts. The pain and the suffering, and knowing that like yes, you can just look up how a flip flop works if you already know what a flip flop is, but you're supposed to figure it out again from scratch.
Yeah, I did my that was another thing is I did my best to not cheat at all. There was something I think it was like an XOR gate or something. There one of these gates where like I felt like there was an incredibly simple solution, but I had an incredibly convoluted solution because I didn't want to cheat. All right, on to the topic DevOps or developer operations. Patrick, what is DevOps?
All right, this is a fair question. So words are hard, but DevOps I think is in the set of responsibilities that take you from compiling your code, testing your code, deploying your code, the sort of life cycle of your code into an application from development and into production and the processes that go around that.
Yeah,
Uh,
that's right. I feel the same way. What is I've heard of site reliability engineer. What is that? Is that the same as DevOps or are they different?
So this is a fair question. I had to double check just to make sure my thinking around this was good because sometimes you end up with a experiential definition versus a actual definition. So I think SRE is a term that started out of Google but has gained acceptance. And a site reliability engineer is responsible for basically keeping production up and working. And so the two do have in some ways overlap, but SREs are responsible for the production environment. So making sure that databases are staying performant, websites are staying up, monitoring traffic, alerting if something goes down, and either restarting it, fixing it, whatever themselves, or involving engineers or DevOps in sort of that. So DevOps can definitely make an SRE's job a lot harder if they're not doing a
Yep.
good job helping to check along it. But SREs are really the people responsible for keeping it up and going in the end.
Yep. Yep. That's right. Yeah, and DevOps is extremely, extremely important. Outages, I mean, depending on where you work, outages may or may not make the news. They definitely, have a huge impact on your company. If people feel like they can't trust your company to be up all the time, that's going to create problems. I mean, as I said, when we were on vacation and we lost mobile data, had like a huge impact. And one of the things we thought is maybe we shouldn't have the entire family on one plan.
Mm.
I mean, we're still going to do that because it'd be a huge hassle otherwise. But it made us think about that, right? So like that. So I think it can have a huge impact on your business, your company's reputation, also your engineering time, right? So if DevOps is done correctly, then your engineers are getting very quick feedback. Anyone who's built something knows. You ever go back and look at your code from a year ago? You're like, what idiot wrote this? Like this guy needs to be fired. And then you look at the top of the file and it's your name on it or something, right?
No, never done that.
Never happened. So, so if you have a problem that you don't find for 3 months, you've lost context, you've moved on to something else. If you have a problem and you find out in 5 minutes, well, that's a totally different story, and you can rectify that pretty quickly. at worst case, you can roll back, even if you don't know what's causing it. You can at least roll back 5 minutes, and just say, okay, well, let's take our time and figure this out. If it's a problem that's maybe been there for 3 months, and people are just starting to hit it now, that can be extremely stressful. Um, for your engineering team and for yourself. So DevOps is meant to address all of these issues, and it's absolutely critical if you're doing any type of software that goes to other people.
Yeah, I mean, Jason mentioned, outages potentially making the news, but I mean, it can be an absurd amount of money if you think of something like Amazon, going down. And everybody's role is to make sure that doesn't happen to some extent. But even in, like you mentioned, in smaller companies, if you're trying to, if you can't figure out why something is acting different today than it did yesterday or the day before, and like you're doing a lot of running around because of some of the techniques that we're going to talk about, that DevOps not just being a specific person or group of people, but really everyone's responsibility to do some of the stuff that's involved in this, and really making sure that you can quickly get to the bottom of what's going on. Nothing worse than banging your head. If you ever encountered that, like, my code, I haven't changed anything, but it's doing something completely different, or I changed this one line and everything is different. It's very, very frustrating. And that can happen in more than just your compiling if you're not careful.
Yep. That's right. So yeah, jumping into it, maybe we'll just start. So the general DevOps cycle is build, test, release, and so we'll structure this episode in the same way. So looking at the very first step there, building, um, building software that you tend that you intend to give to someone else or to another machine is actually really hard. We've talked about this in the past, but um, you have a bunch of libraries on your machine. So stepping back a bit here, you have your operating system, which has a bunch of core C libraries. Then you have a whole bunch of packages that you've installed, OS packages, and then some of those packages are themselves package managers, like Python's pip or npm. So you have all of that context. Um, and so if you build a piece of software, it could be using any or all of that context. And then you give that software to somebody else or to a machine in the cloud, or to a customer. And that software doesn't work, right? Or it doesn't work the way you intend. And so this is called, I always have a hard time saying this name, but it's idempotency. Idempotency. And what that means is something is idempotent if it has no external dependencies, right? And so imagine like a function that doesn't use any global variables or system calls or anything. That function has no external dependencies. Every time you call 2 plus 2, you get 4 every single time, no matter what the context is or time of day, anything like that. And so you want your build system to be like that. The challenge is it becomes kind of like getting 100% test coverage, where it just becomes exceedingly difficult to sort of get that much idempotency. So, for example, one really popular tool for building software, at least in C, C++, and Python is Bazel. So Bazel, what you can actually do with Bazel is you can actually have Bazel build its own compiler, and have Bazel build its own C libraries and all of that. And then you have, when it builds other software, it's using those compilers and C libraries that it built. And so that's kind of the ultimate. I mean, I think the ultimate idempotent solution is, Bazel runs inside of a Docker container that has like an empty Linux image. And inside that Docker container, Bazel goes and builds everything from the ground up. Now, again, that's extremely expensive. There's a bunch of challenges there. It's hard to actually execute that. And so for most people, they don't need to go that far. But just using Bazel at all is a good first step to get idempotency.
Yeah, I've heard this called hermetic builds as well. I'm not sure if there's
Yeah.
a slight difference between the two, but I think, like you mentioned, there's the first line of things, which is, hey, we pin all of the libraries to a known version. Everyone's on the same OS version, and you can get 99% of the benefits that, if things are reproducible across everyone's, but it still may be, I'm trying to think of like some specific examples, but depending on what you have in the build as well, not just your build infrastructure, if you go to the level of, I want the, hash of my output binaries to be identical no matter whose machine I build it on. Like it is literally bit identical regardless, then you can end up with, all sorts of interesting things that are getting picked up or used, or the ordering of things, or, if you really, really go to an extreme that everybody's machine builds a bit identical binary, it can take a lot of running things down and making sure that things are exactly as you think they are. But the big unlock of having, as Jason mentioned, even like building it from source is one, but at least knowing the version of something that everyone is on is definitely super useful, and what everybody's depending on. Because if you do none of it, at the opposite, it's not just that your builds aren't reproducible, but I've had this on teams. Someone sends you something, you can't get it to compile because there's 15 dependencies that aren't called out anywhere because they just got picked up from their computer. And so you need to one by one resolve, brew install this, pip install that, and you're just going at it one by one by one, trying to find the set of packages to install, and it's super frustrating.
Yep. Yep. Yeah, exactly. So, getting it completely hermetic or idempotent is really difficult. One thing that's a nice middle ground, which I think is the most popular approach, is to have a build server which matches your production hardware. So imagine if you are deploying a website to an AWS EC2 instance, you probably don't want to build that website on your desktop and copy it over. You probably want to do at least that final build on another EC2 instance with exactly the same specs and hard and software setup. That way, if there is a problem, let's say you're running the GCC 10 and or like libc 2.13, and they're running 2.6 on the cloud, then what will happen is the build will work fine on your machine, but then when you try to do that final build before pushing it to customers, that final build would happen on this EC2 instance, and it would throw some error, and at least you would catch it before it made it to the production servers. And so there's a bunch of tools for this. This is called a build farm or test farm. There's a bunch of tools for this. I've used BuildBarn in the past. I've also used Jenkins. There's GitHub now has GitHub Actions, and so these do a lot of different things. You can run commands off triggers, but at least in the case of BuildBarn, it also is just transparently hooked up to Bazel. So the way it works is you configure your Bazel. Bazel actually has an API for submitting jobs and getting results back, and so you can set up Bazel to point to a BuildBarn instance and say, hey, you can build the code locally on my machine, but you could also build it on this BuildBarn instance. You could also say like only build it remotely, don't do anything on my machine. And then you could have a lot more control over the machines that are doing the building. Um, and then when you go to actually build the release candidate, maybe you do that every day or once a month or what have you. You could use something like Jenkins, which would spin up a machine in the cloud, do your build on that clean machine, and then tear it down. And so, getting a good handle on these tools is super important.
I noticed we did skip over one thing that we probably just took for granted, which is having code in source control and every commit being checked that it builds. So we're talking about building it, but all of this starts from a basis that, you're not compiling code that's, a thing, or that main branch is currently broken, or whatever, you're on is not buildable. And that everybody knows that you just had to do these 6 things, and then, and then it builds. It's been on that before. So
Yep.
you aren't allowed to merge to main unless that's proven that that branch afterwards will be good.
Yep. That's a good point. Yeah, I think. Um, yeah, I mean, this is there's a lot of complexity there, but yeah, I think on the surface level, you should have a set of smoke tests and say, look, if this PR breaks one of these tests, if the Bazel test command isn't clean, then we can't merge a PR, or you need like a special override flag or what. Um, so I think, you know, there's sort of a meta point here, which is, we've talked a lot about setting up, build farms and testing farms and Jenkins and all of that. But then there's this meta question of like, how do you set that up? How do you guarantee that your Jenkins cluster, matches your production cluster? And if somebody, let's say, upgrades the production cluster to Ubuntu 22, but the build cluster, they didn't update the build cluster to Ubuntu 22. How do you keep those errors from happening? And the answer is this concept called infrastructure as code. I think it's also the acronym is IAC or IAAC. They take the A in infrastructure. And so what you want to do here is you don't actually want, in a corporate setting or a business setting, you don't actually want to go into the Amazon web interface and like click through and create a new VM and assign it an Ethernet adapter. Like doing these things is great as a hobbyist, or if you're doing a research project or a one-off thing. But for production, you don't want to be using the Amazon or Google Cloud, any of these UIs and spinning things up, because you might just click an option that someone else didn't, thinking that's the right way to go, and then it becomes really hard to debug that. Or what if you need to spin up like a ninth machine, but Bob span up the first 8 machines and Bob isn't there, and so everyone's waiting for Bob, right? So what the most popular tool for this is, or language for this is Terraform. Terraform is a tool and a language, I believe. There is a .tf files that have their own domain specific language. There's some some drama around this where I guess there's like an open source fork, and HashiCorp, which runs the closed fork. There's some issues there, but I think from what I've been reading, Terraform isn't going anywhere, and it's not going to get completely proprietarized or anything like that. So I'd highly recommend Terraform. The way it works is it's really clever. So Terraform looks at your cloud. Whenever Terraform okay, let me take a step back. So Terraform is this script that procedurally like lists a bunch of things that should exist. Like you should have this VM, it should have this much memory, it should have this, Ubuntu image on it, and then it should also be able to tunnel through to this other VM, et cetera, et cetera. And so the first time you run this, you have an empty cloud. And so Terraform goes through the list and creates all of those pieces of software infrastructure, right? But when it creates them, it puts special tags, and then it creates this cache file, which you put into your source control, and that keeps a history. So Terraform knows, hey, Terraform, created this VM from this Git commit of Terraform code. And so then all you have to do is change that Terraform file and say, oh, actually, it has 32 gigs of RAM. And then the next time you run tf apply, Terraform, again, because it's tagged everything, it knows what it created versus what Patrick created. And so it looks at all the things it created, it looks at the new Terraform file, and it realizes what it needs to change. And so it will actually just add RAM to a VM or rename it or something like that, instead of just deleting everything and starting over. You can, as you would expect, you can do weird things that make Terraform very confused, and then it's like, I don't really know how to fix this. But if you're not trying, you'll almost never have a situation like that. In practice, Terraform pretty easily knows, how to make that leap. And so this will help guarantee that everything's on the same page. So imagine, you'd have one place in Terraform that says, this is my production Linux image. And someone just changes that one line to like Ubuntu 22. And under the hood, Terraform might like reformat 1,000 machines, but it's going to do it all in one step. And that's going to keep inconsistencies popping up.
I think for, not only being able to do that, but also having as code checked in and a history of the changes is, of course, definitely useful. So having something that you can have other people approve before you just apply, because I think that's another instance everyone's heard about is someone goes in and just makes a change and nobody knew or wasn't documented, and then everything's broken and no one knows why. So.
Yep. Another popular thing to do is what's called blue-green deployment. Have you heard this term?
Is that A/B deployment?
Pretty much. So
okay.
Blue-green just means you have two copies of your infrastructure. And so, for example, like the upgrading Ubuntu example. So you want to upgrade all the machines at once and just have one clean atomic operation. The problem is, of course, it takes time to upgrade 1,000 machines. And so you don't want your website to be down while you're doing that. And so blue green is just a fancy way of saying have two copies. And so you upgrade the first copy. And while you're doing that, all the traffic goes to the second copy. And then you switch the traffic over. And so it's kind of like if you've ever done a ropes course, you know how like you have two harnesses. And so you disconnect one harness from a rope to connect it to another rope. But if while you're connecting it to other rope, you fall, it's okay because you still have the second harness. And one time I went to a place where I don't know how they did this, but it's some kind of mechanical or magnetic thing where basically if I think it was a circuit. Like if you hadn't completed the circuit by locking one of the locks, then the other one couldn't be opened. So like you physically couldn't unhitch both of the harnesses at the same time and do something dangerous. And so blue green is kind of like that, where while you're making a change to blue, you can't send any traffic to it, and then it flips.
I think not only this being singular stuff, but I think part of what we're talking about is leading to making sure that all of these things are repeatable and that they happen frequently. So saying, oh, we haven't deployed a new one of these or checked on anything in a month or 3 months or 4 months or 6 months, you build up a lot of changes, assuming your code's going under active deployment or packages that you're using are getting upgraded, and security vulnerabilities we've not talked about, but monitoring and updating because of those. And so making sure that you're continuously integrating your code into the system and then deploying those things out at some cadence. I mean, it's not in the mathematical sense continuous, but just doing it at a constant repetitive interval prevents there from being large, gigantic changes. And it somewhat becomes a self-fulfilling problem where you wait a really long time because each time you do it is hard, but then the longer you wait, the worse it becomes. And so then, of course, it's hard because more stuff has changed and more stuff can break. If you're doing that process of build, test, deploy, just consistently and constantly, then there's really not too much to be afraid of. And so you may still have a acceptance testing phase in there or whatever. So it's not, although it has its own merits, but it's not the classical build, go fast and break things. We're not saying it has to be that way. It's just being always in the process of doing these things. So they're not we do this once a year and everyone forgets what to do in the meantime.
Yep. Totally right. And once you have a lot of this automated and in code, then you can do this continuously. Imagine if you had a software librarian who was, cutting a release every 5 minutes. It's just not practical.
I mean, to be clear, there is a role, software librarian. I'm sure in some companies they're still there, but I think we used to work at a place that had a software librarian who, at a once a week interval, actually was responsible for making sure all the code compiled. I would not recommend that.
Yeah, no, I wouldn't recommend that either.
But to your point, they couldn't do it every 5 minutes. So they got kicked off to say, hey, once a week, it is this person's job to take all the code, review all the changes, make summary reports, and what we now just do constantly with computer systems, they would do by hand.
Yeah, exactly. Yeah, I remember getting just like software librarian coming over to my desk. Hey, so broke the build again. It's like, now we have a machine that continuously comes to our desk.
Now
And
GitHub puts you on blast.
yeah, that's right. Have you ever done anything interesting, like any interesting real life triggers? I'll tell a couple from my background. At one point, we found a way where, okay, you know those, what are they? They're like cardboard, but they can be life size, like life size
Cardboard
cardboard.
cutout. Yeah.
Yeah, like statues, I guess is what you'd call them. Um, so there was this one guy who kept breaking the build, and we found a thing. I think it was Zazzle or something, where we could get a life size cardboard cutout of this
Of them.
engineer.
Okay.
And we had a Raspberry Pi or some Arduino, something set up where his eyes, we put LEDs for eyes. And whenever the build broke, the LEDs flickered. What's the craziest build breaking thing you've seen?
I don't think I've only ever been on one team I think did it. They had some stuffed animal that they would, take from to whoever was like most recently, screwed something up, and they would take it to them, and that they would, put it on their desk or whatever because they were the most recent person up. But in general, I've always heard stories, or there's a lava lamp somewhere now still does that. There's like lava lamps because they take a while to heat up and start going. So if the build is broken, the lava lamp turns on, and then you got to try to fix it as fast as you can so that the whole office doesn't see that the lava lamp is happily bubbling away and the build is broken.
This is amazing. We should have like a New York Times Square style ball that drops from the ceiling, and if the build is broken for a whole day, it hits the ground, and then it
opens up, and there's a pink slip.
I was thinking there's like a kaleidoscope of multicolored lights, but yeah, maybe firing is
just opens up, and there's a little receipt printer.
A dot matrix printer prints your pink slip.
Yes, that.
Oh man. Oh man, that's so good. This is another reason why we need a hybrid workplace so that we can taunt each other. Just working remote just isn't the same. Oh man. Okay, so how do we measure good and bad DevOps? I think is a really interesting part of this. One thing actually, maybe I'll start by saying you should measure it. In general, my philosophy here, maybe this is like a pessimistic view, but if you don't measure something, you should expect it to be the worst thing possible. That's kind of my overall view of it. And so, or maybe like the worst within some like common sense reasoning. And so DevOps is the same way. If you don't measure it, then it's not going to be very good. Or what another thing that I've seen happen where you don't measure something, and what actually happens is a few people heroically kind of keep it up and running, but then they end up getting burnt out and just feeling like they're not really productive and hurts morale. So measuring things extremely important. How to measure DevOps? I'll just start with the simplest one: build times. Build times, test times, deployment time. Is it taking 3 weeks to build your deployment image? That's a huge problem. Our engineers just sitting there like wrapping their fingers on the desk waiting for the build. That's not good. And so just having a graph of that, I think, is a good place to start.
We didn't talk too much about that, but I think you're absolutely right. Like builds, if not managed properly by everyone, they become sprawling and take a long time, and it really kills your ability to iterate. So it's very valuable to do what you can to make sure your builds run fast.
Yeah, I heard a story from the games industry where they weren't using DLLs. There was this philosophy that like we just want one exe, and the linker was taking like 90 minutes, and then at some point somebody just broke the paradigm and said, look, we're going to put DLLs, and we'll put the DLLs in the same directory as the exe. Nobody will even notice. And then the linker took like 40 seconds or something. But people were waiting an hour and a half. It's like, oh, I missed. Well, I guess if you miss a semicolon, you get a compiler error. But it's like, oh, this number was a 3, it should have been a 4, 90 minutes. And that just destroys the morale and the productivity. Another thing that's really important are things like release cadence, um, things like bug tracking. How long does it take to fix a bug? What's the bug rate, per week, and trying to get that number down. And then the last one, which is the most important, are surveys. People hate surveys. I mean, outside of work. If someone comes to your door and wants you to know, you like, are you voting for this school board member or something, or tell us, the survey on like this, or, do you have energy efficient lights? Like, it feels like one of these things that you just want to slam the door in somebody's face. But at work, especially if it's done right, surveys are extremely important. Um, you know, one example of a case where surveys worked really well, when we built the machine learning backend at Facebook. Whenever someone canceled a job, there was a survey, and the way it worked is, they could click cancel, and then just there was a submit button they could submit, and the survey wasn't in any way forcing people, but there's a little radio button, said like, why are you canceling this job? Again, you didn't have to choose, but you could choose like, you know user, I think it was called like, I don't want this job anymore, or there's a choice that was like, I made a mistake. Then the rest were all infrastructure, like the job isn't finishing, or the system has crashed, or the machines keep going down. Like, there's a whole bunch of choices that were all relevant to things we were trying to do better. And then when you clicked one of those, it popped up a little feedback form, free form, and that was unbelievably useful. So for one, it immediately set a target so people could try to like, do better on those forums, or get the button press, radio button press rates down. The second thing is the free form gave us like a whole bunch of really useful context. And what we end up settling on, which I think every company should do this, is a regular survey where we ask people like, what is their percent time doing work that they enjoy, and then calling out like, what do they not enjoy. um Now some of these things are, oh, I don't enjoy that, like, we don't have chocolate milk or something. Okay, it's like, okay, that's fine. But some of them were like, hey, I don't enjoy just sitting here waiting for my build for an hour, right? And that is extremely useful information.
Have you ever personally, like on any of the teams you've managed, ever done like a survey? You made me think. I don't think I've ever done that. I've always had like higher level organizational surveys, but have you ever done a survey of just like, send out, hey, everyone, send in information about stuff specific to your team's roles?
Yeah. So, it's a good point. I'll do it at a low cadence because, the company will do a survey every quarter.
Sure.
And so sometimes I'll ask for questions to be added to that survey. But no, I think, I'm trying to remember if it's twice a year or once a year. But yeah, we'll do a survey and we'll ask, basically, how's it infrastructure? What are things that are slowing you down? What are things that like frustrate you? And yeah, I think it's extremely nice to get that feedback.
I'm gonna have
One
to do that. I think that'd
interesting,
be cool.
yeah, one interesting thing about surveys is, the best results are actually from the people who are the most reluctant to give feedback.
Mm.
Not because they're afraid or anything, but you'll have the people who are angry and the people who are ecstatic. You get the feedback from them like that day, right? But it's the people who are like on the margin, and the people who are like, oh, I'm too busy to do this survey. Those are actually often the people who have the most interesting things to say. And so it becomes really difficult because you really have to push for, as close to 100% feedback as possible, because as you get closer to 100%, the data gets richer and richer. All right.
Awesome.
So I guess we'll end it with any DevOps horror stories. I'll tell one real quick. This wasn't a company I was working at, but we hired somebody. This was, oh gosh, probably like 10 years ago. We hired somebody who's telling me a story about their past company, which was a startup. And they had this, so all of their code was Tomcat, which was this Java web service library. And so the way it works is you create a jar file, and the jar file, I don't think it spins up a web server, but I think it answers web requests, and then you hook it up to a web server. I'm starting to like get a little hand wavy here, but basically a jar file, for folks who don't know, is literally a zip file. It's a zip file that has certain files in certain places of the zip, and it's just renamed to jar. That's what it is. Um, so this jar file like knew about how to handle web requests, and it had a bunch of Java bytecode in it. And the way they would do DevOps or deployment is when they made changes to the source code, they would remember what files they changed, like what .java files. They would take those .class files from their machine and they would inject them, like replace them in the jar in the zip. So they would like SSH into the production machine that's serving all the customer traffic. And they would open this in like a zip editor and they would drag their class files from their machine. And the website, he said, would go down like once a week because of this, and no one would know how to fix it.
Oh, wow. I don't think other than like having an actual software librarian, like we were talking about being ridiculous now, I don't know that I have any particular horror stories.
What about like downtime? Have you ever been on the crunch where something went down?
No, see, we did mostly like internal facing stuff. So we've never had like a problem with like SLAs, but I guess we've had issues, just the kind of normal stuff like somebody built, with on a machine that had like a really old version of a library and we didn't even know. And then, like for some reason, the code that everybody was trying to run would just not work. We couldn't figure out why. No one could reproduce it. And there's always this thing when you can't reproduce some problem to just hand wave and say, well, it's not broken now. But then every time they would build it, it would have the same issue. And so finally we tried to figure it out, and it turned out, oh yeah, like you need to upgrade this library. Like this library had a known bug in it. You missed the email that told you like, please update.
I got one last story. This is what happens when DevOps goes too far in the other direction. I was at this place which the PRCI, so in other words, the tests that run when you have a pull request that you want to get merged in, were taking like a day. And somebody pushed a change where it was a JavaScript or a React bug that they introduced where basically the submit button was never available. Like it was always grayed out. So you could like create a machine learning job to define the job and everything, but you couldn't click the submit button to actually launch your job. And so people were having a hard time. And I said, for now, let's just like always let people click the submit button. And like if people submit a bad job, it'll just fail on the back end. And that'll just get us through today because a bunch of people are upset about it. So I submitted just a one line change. So literally in the React, it just like in the submit button, the code that's like active equals a bunch of logic. I just deleted that part of that HTML tag. So the button could always be pressed. And then the PRCI took like half a day and then failed because of like some other change. And basically like, people were super upset and I couldn't get this like one line HTML change in for like 2 days. It's just a total disaster. So I think that's a case where a lot of tests were running, and I'm sure they're catching things in general, but it was also kind of destroying productivity in a different way.
Yeah, that's true. We didn't talk about that. Sometimes you may need to just do the crazy thing and just push a change and just get rid of all the other stuff because it's in a bad state, and the bad state's not letting it get out of the bad state.
Yeah, that's right. So yeah, I mean, software librarians probably not a thing anymore, but DevOps is going to be a thing for a long time. DevOps is not going anywhere. If this kind of stuff is really interesting to you, you could definitely get a nice career for many years doing DevOps, and I think it's a great field.
Well, thank you everyone for listening through another episode, and appreciate all of our listeners, all the feedback, and people on Patreon. So definitely a shout out to everyone who makes the world go round.
Yeah, totally. Thanks everybody. We'll catch y'all later. Have a good one.